In 2017, a woman shared a story on Reddit that challenged her understanding of reality. She woke in the middle of the night to a text message on her phone. When she checked the screen, the message was from her husband, who was fast asleep right next to her, his own phone sitting untouched on the nightstand. The message asked, "Who is this?" Confused, she replied, only for the sender to claim they didn't know her, even though her number was saved in their phone under a highly specific pet name, Wi-Fi with a heart, a name only her husband used. This sounds like a digital ghost story, but physicist Michio Kaku offers a framework that moves beyond the paranormal. He suggests that if two timelines in a multiverse were to cross, information, including human memories and digital data, could theoretically exchange between them. This would manifest as a sudden, jarring sensation of familiarity, much like the déjà vu experienced by nearly 80% of people. If our consciousness is governed by the same quantum processes as the rest of the universe, a crossover event would leave a physical footprint. To determine if these stories are more than psychological glitches, scientists first had to investigate if the universe could even produce a multiverse. Proving Kaku's theory requires looking past a massive physical barrier. Human beings are restricted by the speed of light, meaning we can only observe the parts of space that light has had enough time to travel from since the beginning of time. This creates a rigid boundary called the cosmic horizon. It represents the absolute limit of our observable universe. No matter how advanced our technology becomes, we cannot see what lies in the dark void beyond this sphere, making it seemingly impossible to confirm the existence of anything outside our own bubble. Since we cannot travel beyond the horizon to look for other universes, physicists realized they had to reverse the problem. If they couldn't observe the multiverse directly, they would have to recreate the exact conditions of the Big Bang inside a laboratory to see if a multiverse is a natural byproduct of creation. To validate these strange human experiences as physical events, researchers launched a scientific investigation into the very birth of space and time. In 1977, physicist Sidney Coleman drafted the mathematical framework for how our universe transitioned from pure energy into the matter we see today. After the Big Bang, space was held in an incredibly unstable state called a false vacuum. It appeared stable, but it was actually vibrating with a massive amount of trapped, chaotic energy. Coleman compared this to a pot of milk on a stove. The surface looks calm, but intense energy is building up underneath. The particles at the bottom are heating up, desperately seeking a way to release that tension and reach the surface. The newborn universe was exactly like that heated milk, a ticking time bomb of trapped energy that needed a specific mechanism to cool down and stabilize. The particles of the early universe had two paths to reach stability. They could slowly cool over an immense period, or they could find a sudden, drastic shortcut. At a macroscopic level, you have to climb over the mountain. But at the ultra-microscopic level, quantum particles can defy standard physics. They faced a massive energy barrier that should have been impossible to cross. Through a process called quantum tunneling, these particles punched directly through the barrier rather than climbing it, taking an instantaneous shortcut to a stable state. This shortcut had a massive physical consequence. As the particles tunneled through, they expanded into isolated pockets of a low energy state, essentially boiling over into distinct, perfect bubble universes. Coleman's model suggests that the Big Bang birthed an infinite landscape of these expanding bubbles. In this scenario, our entire universe is just one pocket of stability in a much larger, boiling sea of realities. This math provided a clear blueprint for a multiverse, but it remained a hypothesis. To turn this into fact, science required a physical demonstration of this boiling process. Fast forward to the present day at Trento University in Italy. Here, researchers finally constructed a physical experiment to test if Coleman's 1977 math holds up in the real world. The team took sodium gas and supercooled it into an ultra-stable state called a Bose-Einstein condensate. This created a laboratory environment that perfectly mimicked the tense, false vacuum of the early universe. They then applied a powerful magnetic field, forcing the atoms into a rigid alignment. This created the same extreme tension that existed just fractions of a second after the Big Bang. To trigger a transition, the scientists bombarded the gas with targeted radiation, simulating the massive energy injection of the early universe. As the radiation frequency peaked, the atoms began to flip their magnetic alignment. They tunneled through the energy barrier and grouped together, forming microscopic, highly stable bubbles within the gas. By observing these transitions in a lab, the team provided the first physical evidence for the quantum mechanism that allows a multiverse to exist. They demonstrated that when space is under enough tension, it naturally boils into multiple, stable realities. With the mechanism proven in the lab, the final step is to find evidence of these bubbles in deep space. If our universe is part of a multiverse, there should be physical marks where other bubbles have collided with our own. Scientists are looking for these marks in the cosmic microwave background. This oldest image captures residual radiation from the Big Bang. Astrophysicists are searching this map for circular anomalies, potential bruises where another expanding universe bumped into ours, as the experiment suggests. The next time you experience an unexplainable moment of déjà vu, or a story that seems to defy the laws of probability, consider the physics. We are beginning to see that the strange echoes of human experience might be grounded in the reality of a boiling multiverse.